In this lecture, we will talk about defining the derivative, which is related to the rate of change. Okay. First, let's talk about the average rate of change. The average rate of change is the slope of the secant line. This is the secant line right here. Between x equal to a and x equal to b on the graph of f. That's it. The line pass through AF of A, which is this point here, and BF of B. Okay. Then this line right here is what we call the secant line. Okay, so if you remember, how do we find the slope of a line? Then if we have, okay, if we have point P and point Q, and then this is x1, y1, this is x2, y2, and remember the slope is y2 minus y1 over x2 minus x1. Okay. This is exactly the idea about the average rate of change if you convert it to find the slope of the secant line then. Okay. Where consider that this A is x of 1, f of A is y sub 1, and B is x of 2, y is y sub 2 is f of B. Okay. Then we plug it in the formula y2 minus y1 over x2 minus x1. Okay. Yeah, this is how we work with the average rate of change then. Okay. Then now, let us look at our first example. How do we find the average rate of change from a table now? Okay. So I would like to find the average rate of change in between on the interval 12 to 20. Okay. So how do we actually set it up? Then follow this. We will have, in this case, then now this 12 is A, this 20 is B, right? Okay. And now we will have W of 20 minus W of 12 divided by 20 minus 12 then. Okay. Then from this table, W20 is 33, and then minus W12 is 26, and then we would like to all over 8. And then now we find out that is 7 over 8. So then this is my answer, right? So now if we have a functions, then how do we actually work it out the problems? Okay. So to this one, same thing, I would like to find average rate of change on the interval between 1 and 9. Okay. Then my first step is I'm going to set it up. So then I will have f of 9 minus f of 1 over 9 minus 1. Okay. Then right now, if we work with the function notation, so f of 9 basically is mean that 9 minus 2 times square root of 9 then, right? Okay. And f of 1, again, basically we replace x with 1 minus 2 times square root of 1. Okay. Okay. And let's see how we work it out the problem. So I will have 9 minus 2 times square root of 9 minus, okay, we subtract the whole thing f of 1. Okay, so it will be 1 minus 2 times square root of 1. And now I divide everything by 8. And, okay, so then now let's simplify. So I have 9 minus 2 times 3. And then minus 1 plus 2. I will have, so then now I will have 9 minus 6 minus 1 plus 2 divided by 8. So I will have 4 over 2. And then we want to simplify this. So my answer will be 1/2 then, right? Okay. Remember, when you work on the test problem, you always simplify your answer. And now another way to talk about the FAV of change of f is at A is, instead of giving you the B, we give you a distance, okay, H. So if you start with x equal to A, and then if you add the distance H, meaning the next point or the next number, it will be A plus H then, okay? So that means in this case, we will have to this point A is corresponding to the output is f of A. To this x equal to A plus H, then the output, it will be f of A plus H. Okay. So that means I will have the point A f of A and the point A plus H, f of A plus H. Then, okay. Then now, let's see. So again, this is x of 1, this is y of 1. This is x of 2, this is y of 2. Okay. Then now, what we have here, we will have this, okay? So the FAV of change over the interval A and A plus H, it is f of A plus H, the y2, minus f of A, the y1, all over A plus H minus A, okay? So then now I will have f of A plus H minus f of A all over H. This is exactly how we get this form right here, okay? Okay, so then now, let's see how we work it out the problem now, okay? So again, we are going to start with setting up, right? Over the interval 2 and 2 plus H, okay? And it is equal to f of 2 plus H minus f of 2 all over 2 plus H minus 2. Okay. Or you could just write down f of 2 plus H minus f of 2 over H then, okay? Then now, let us evaluate this, okay? Now, one thing about this is I have, that means I have some student, when they work with f of 2 plus H, they don't know how to take care of this, okay? Then let's see how do we actually take care of f of 2 plus h, okay? Now, one thing about this is when you have polynomial functions, f of x equal to, for example, 2x squared plus 2x minus 5, okay? What does this mean to me? Essentially, it means that x is the input. So we could consider that x could be any input. Then now I will have 2 times the input to the square plus 2 times the input and then minus 5. You could consider that x basically is just a box. This box right here could contain anything you want to put it in. Then if you want to put in, for example, like x plus h, okay? If this is the expression that you want to put it in, then again, you are going to replace the box with x plus h, okay? So this is the idea, okay? Okay, so now let us go back to the problem. To this problem here, I have the function is f of x equal to negative x squared, okay? Then in this case, I could consider that okay, so you have f of the box equal to minus the box to the square, okay? Then now if you want to put 2 plus h, I mean you want to put 2 plus h here, okay? Then let's see. So now to this one, it will be negative 2 plus h to the square, okay? Then we subtract. How about f of 2? So it will be negative 2 squared then, right? And then everything over h. Now, and then mistake that a lot of students made is when they work with binomial square, okay? So again, if you have a plus b to the square, you will have three terms, which is a square. So maybe let me do it this way. So it will be a plus b times a plus b, okay? So then now we FOIL this, right? So I will have a square plus a times b plus ba plus b squared. So meaning we will have a squared plus 2ab plus b squared, okay? So then this is actually the result from a plus b to the square. We have three terms, okay? So that means to this one right here, I will have 2 is the first term, so I will have the first term square plus 2 times the first times the second term. And then we are going to add the second term square, okay? And of course, to this one, I will have minus, in this case, this is negative 4 here, over h. Then let us simplify this. So I will have negative 4 minus 4h minus h squared plus 4. Okay. And then you will see that negative 4 plus 4 cancel. So now I could take out the h. Here we have a common factor h, right? So we could take out the h. Then I have -4 minus h divided by h. Okay. Then h and h cancel. My answer will be -4 minus h then. Okay. Then now, let's see what does this mean by this expression right here, -4 minus h. Okay. Okay. So and now let me erase this stuff first. So I have the function -x squared. Okay. And now we have this is 2 right here. And then this is the distance from here to here is h. Okay. Then of course, this one right here will be 2 plus h. Okay. So corresponding to these two, this is the output that we have here on the curve. Y equal to -x squared. Okay. And then to 2 plus h, this is the output that we have. Okay. Okay. So again, to this point, it will be 2 f of 2. And to this point, it will be 2 plus h, f of 2 plus h. Okay. And now, we have a secant line between these 2 points. Then the slope of this secant line right here is -4 minus h. Okay. So this -4 minus h basically is the slope of the secant line between x equal to 2 and x equal to 2 plus h. Okay. So what does this mean to me? It means that if, okay, for example, if h equal to 1, meaning now we have the point is from 2 to 3, instead of working out the every way of change between 2 and 3, we could use this formula right here, right, to plug it in. So the slope of the secant line or the every way of change, maybe I should between 2 and 3, right, is equal to -4, okay, minus 1, which is -5. We will be able to get the slope of the secant line between x equal to 2 and x equal to 3 right away. Okay. And now you will see that from now on, we will work on a lot of problem related to the tangent line. Okay. So then now let's see what does this mean by tangent. It said that a tangent to a curve is a line that touch the curve at one point. Okay. For example, if this is the point, then this line right here is the tangent line. Okay. And then now you will see that a lot of problem later on will ask us to find the equation of the tangent line. Then let's see how do we actually, again, work it out or maybe finding the tangent line now. First of all, I would like to see how we actually find the slope of the tangent line first, okay? Then now consider that right now, I would like to find the slope of the secant line between P and Q. Then now, what if the point Q is moving closer and closer to P? Okay. Do you see that the slope of the secant line, okay, or maybe the secant line and the tangent line, they become, I should say that the secant line when Q is getting closer to P become the tangent line. Okay. And now look at the other way around. So in this case, again, this is my secant line. Has P moving closer and closer to P, then the secant line, right, is approach the tangent line. So in some sense, as Q approach P, then the slope of the secant line approach the slope of the tangent line. Okay. This is kind of like the idea. So based on these observations, we get to our definition now. The tangent line to the curve y equal to f of x at a point P, a f of a, is the line through P with the slope. Okay. We take the limit as x approach a of f of x minus f of a over x minus a. Okay. Then in this case, we call this f prime of a. Now let's see what is going on. First of all, let us look at this expression f of x minus f of a over x minus a. Okay. Now, let's consider that this point Q with the point is x f of x. And then now this point P with the point at x equal to a, so I have a f of a. Then do you see that as x getting closer and closer to a, what happened to the point Q? Point Q is, again, of course, in this case, getting closer and closer to point P. And the secant line, okay, the secant line is getting closer and closer to, okay, or maybe become the tangent line. Okay. And then in this case, the slope of the secant line, f of x minus f of a over x minus a, okay, is the slope of the secant line. Has x approach a, then the slope of the secant line approach the slope of the tangent line. Okay. And then if it's at a, then now we get the slope of the tangent line then. Okay. And in this case, in math, okay, in calculus, we call this f prime of a now. Okay, this is the prime notation. We have another way to talk about the definition, okay, about the slope of the tangent. Instead of giving you x, okay, I give you the distance, again, h. So I have this from a and a plus h now. Okay. So in this case right here, this point, it will be a plus h, f of a plus h. Okay. Again, let's talk about this expression right here. You will see that f of a plus h minus f of a over a plus h minus a is this one, which is the slope of the secant line, right, between point P and point Q. Then. Okay. And then now, as h getting closer and closer to 0, okay, meaning this point Q is getting closer and closer to point P, okay, and now the slope of the secant line become the slope of the tangent line. Okay. Okay, so this is the idea. So then now, to this notation f prime of a, we have a different way to talk about this. Most of the time in physics, we will talk about, we will say that this is instantaneous rate of change of f at x equal to a. Okay. Then, of course, in math, we will say that this is the slope of the tangent line of f at x equal to a, or now new vocabulary, which is derivative of f at x equal to a. Again, these notations, okay? Then now, if I want to find the tangent line formula, okay? Then, of course, we have to remember that the equation of the straight line, right? So again, in order to find a straight line, what we need the slope and a point. Okay. Then we could use the Poinsot form, which is y minus y1 equal to m x minus x1, right? And remember, y1, x1 is a number from a point, okay? And m is the slope of the line. So in this situation, basically is tell you that I have a functions. This is the function f here. Then now, I would like to find the tangent line at x equal to a. Then of course, to this one, we will have the point a f of a. Okay. And now, we also know that the slope of the tangent is f prime of a. If we know all of these informations, then now, if I want to find the equations, okay, of the tangent line, okay, how do we actually do this? Here, first, we need to gather all the information first, okay? First, we need to know the slope of the tangent. In this case, which is f prime of a. Second, we need to know the point. In this case, will be a f of a. And then number 3, we are going to use the Poinsot form. Okay, which is y minus y sub 1 equal to m x minus x sub 1. Okay. And let's see, how do we actually work it out the problem now? Okay. Okay. The slope is the slope of the tangent, which is f prime of a. The point is a f of a. Okay, which is my x of 1 and y sub 1 then in this case. Then now I could plug it in y minus f of a equal to f prime of a multiplied to x minus 8 then. Okay. Then of course, in this case, we could actually solve for y. then I will have f of a plus f prime of a x minus a. Now, to me, I don't want you to memorize these equations because sometimes memorize, if you forget, then how do you actually come with the equation of tangent line, right? Instead, I would like you to actually remember this point slope form. This is how I work it out when the problem asks me to find the tangent line. I use the point slope form to help me to finish the problem. Okay, then now let's see how we actually work it out the problem now. Okay. Okay, so this problem right here is actually asked me to use definition 1 and definition number 2 to actually to help us to work it out the problems. Okay, we have the functions f of x equal to 4x minus x squared at x equal to 1. Okay, so this is what we want to do. Okay, so then now, how do we actually work with the, again, definition number 1 is the slope of the tangent is equal to, in this case, is f prime of 1, right? Okay. Then it is equal to maybe the limit. Maybe let me go back to the definition first. X approach a of f of x minus f of a over x minus a. Okay. And now in this case, we know that a is equal to 1, so we replace this. So I'm looking for f prime of 1 is the limit x approach 1, f of x minus f of 1 over x minus 1 then. Okay, so this is how we set it up. And now, we know that f of x is equal to 4x minus x squared. Okay, then we subtract, and my f of 1 is 4 times 1 minus 1 squared. And then we have everything over x minus 1 then. Okay. And now we are going to take the limit x go to 1 of 4x minus x squared and then minus 3. Then now, let us evaluate the limit. Okay, so again, first, I would like to use direct substitutions. So I found out that is 4 minus 1 minus 3 over 1 minus 1. Then, we have this in determined form, right? Okay, now remember if we have, again, the limit in determined form, we have 3 ways to solve the problem. One is factor it out. Okay. Second, expand it and simplify. Okay. The third is work with the conjugate. Right. So those are the thing that we introduced earlier. But in this case, we are not going to work with the conjugate pair because if we work with the conjugate pair, we need to have a square root in inside the expression that we have. But in this case, we don't have it. Okay. So meaning we could actually use factoring, right? We factor this out. Okay. So in this case, remember, if x approach 1, give me 0, meaning in this case right here, meaning x minus 1 is actually one of the factor. Okay, so then let's see. maybe let me rearrange. So I have negative x squared plus 4x minus 3 divided by x minus 1. Okay. So if you know how to factor, this is great. But again, if you don't know, then maybe we could use symplectic divisions, right? To set it up. Then I will have negative 1 and 4 and negative 3. And then we are going to divide by x minus 1. So we could use 1 here. Then I bring down the negative 1. Then I have negative 1. This is 3. And then I have, okay, well, this is what we are looking for. The remainder equal to 0, meaning in this case, I will have negative x plus 3 then. Okay. Okay. So then it's telling me that I will be able to factor is x minus 1, negative x plus 3. Okay. And now this one and this one cancel. So now we could use direct substitution. Replace x with 1. So my answer will be 2. Okay. So that means my f prime of 1 is equal to 2. So this is how we use the definition 1 to find the problem, to find the f prime. Okay. Then what if I want to use a definition number 2? So which is the slope of the tangent equal to f prime of a. In this case, we would like to take the limit h go to 0, f of a plus h minus f of a over h, right? So this is the definition number 2. And then now, let's see. So which is equal to the limit h go to 0 of f of 1 plus h minus f of 1 over h. Again, how do we take care of f of 1 plus h? Okay, we go to this, we replace all the x with the box. Then, remember, within this box right here is contain the 1 plus h. Okay. That means I will have the limit h go to 0 of 4 times 1 plus h minus 1 plus h to the square. Okay. And now we subtract f of 1. It will be 4 times 1 minus 1 square. Then everything over h then. Okay. Okay. And now, of course, I will have take care of the parenthesis 4 plus 4h minus, okay. Again, it will be the first term square plus 2 times the first term times the second term plus the second term square. And then minus 3. So I will have 4 plus 4h minus 1 minus 2h minus h squared minus 3. Okay. So 4 minus 1 minus 3 equal to 0. Then I have 4h minus 2h is 2h. And minus h squared. And then now we are going to factor out the h. Okay. And we work with the direct substitutions. So my answer is 2. Okay. So you will see that we get the same result. Okay. It doesn't matter which definition we work with, right? Now, my suggestion is try to use the definition number 2 to actually to work it out the problems. Okay. Because when you get to the next section, this is kind of like the how we work it out, the problem then. Then now, let's see, how do we find the equation of the tangent line? Again, remember how we work with the tangent line first. We need to gather in the information, right? We need to know that the slope of the tangent. Second, we need to know the point. Number 3, we are using the point slope form. Okay. So again, point slope form will be y minus y1 equal to m, x minus x of 1, right? Okay. Then to this problem here, my the slope of the tangent line is f prime of 1, which is 2. The point that I have, it will be 1 f of 1. Okay. And of course, okay, again, we know that f of x equal to 4x minus x squared. Okay. So in this case, f of 1 is 4 times 1 minus 1 squared, which is 3. And then we find this. Okay. We have this answer 3 all the time now. So in this case, I have the point 1 to 3. Okay. Then now let's work it out. So I will have y minus 3. Okay, again, this is x of 1, this is y of 1. Y minus 3 equal to the slope 2, x minus 1. Okay. And now I would like to simplify. So I will have, this one is 3 plus 2x minus 2. Then my answer will be 2x plus 1. Okay. And remember, this is the equations of the tangent line at x equal to 1. Then. Okay. So right now, it is your turn to actually to work it out, this problem. Okay. At x equal to 2 now. Okay. So again, to this one, it doesn't matter if you're using the definitions 1 or definition 2. Okay. But again, my suggestion is using definition number 2. Okay. Okay. So let's see. I would like to find the slope of the tangent. In this case, it will be f prime of 2. Okay. Again, I would like to set it up. The limit h go to 0, f of 2 plus h minus f of 2 over h. Okay, so this is what we want to do. And now let's set it up first. Okay. So it will be the limit h go to 0. Okay. So again, f of 2 plus h. Okay. Consider that this 2 times the box to the 3 minus 5 times the box square plus 2 times the box minus 10, right? Okay. So it will be 2 times 2 plus h to the power 3 minus 5 times 2 plus h to the square plus 2 times x plus 2 plus h minus 10. Okay. And then we would like to subtract this one here. Then I will have 2 2 times 2 to the power 3 minus 5 times 2 squared plus 2 times 2 minus 10. Everything over h. Okay. Now, one thing about this is, now later on, you may see a lot of things related to binomial to some power, okay? So then now, maybe let us talk a little bit about how we expand it out then. Now, one way to actually work with the binomial, so the idea is, if I want to work with a plus b to any power n, okay? Then we could actually using the Pascal triangle to help us to work it out this problem. Okay, so what is this about? I don't know if you have seen this type of triangle before. We call this Pascal triangles. And then how do we actually create these triangles? We start with 1 and then 1, 1. And then now, when we go to, again, you will see that the Pascal triangle, the outside is always 1, okay? But the inside is different now. So how do we create anything inside? If you just add these two numbers, so it's 1 plus 1 is 2, okay? And then now we start with 1, and then 1 plus 2 is 3, 2 plus 1 is 3, okay? And then 1. Okay? And then now the next one, the next line will be 1. And now we are going to add this one and this one together. So we have 4. And now we add these 3 and 3 together. So we have 6. And now it will be 3 and 1 together. So we have 4. And then we have 1. Okay. Then of course the next line will be 1, 5, 10, 10, 5, 1. Okay. And then you could expand out the Pascal triangle this way. And then how is this related to binomial to any power? Okay. Now you could consider the first one basically is binomial a plus b to the power of 0. Then you know that any number to the power of 0 is equal to 1. And then to the second line, you will have a plus b to the first power. Then in this case, your answer should be a plus b. Okay. And then what is the one that you have is 1 is the coefficient of the term. Okay. And to this one, we have a plus b to the power of 2. And of course, you know that when I expand it out, it will be a squared plus 2ab plus b squared. Okay. And check it out. The coefficients of a squared is 1. Of the term ab, the middle term, right, is 2. And this is 1b squared. And the pattern, look at the pattern. We start with a squared, and then the next term is a to the power 1. And then to this one, it seems that a disappear, right? But actually you have the term, it will be a to the power 0 then, because a to the power 0 is 1, so we didn't write out. Okay. And then now look at the power or the b now. So again, to this one, you have the term b to the power 0. But again, b to the power 3 is 1. So it didn't appear here. And then b to the power 1 and then b squared. Okay. Okay. Then now let us look at the third. So I will have a plus b to the power of 3. First of all, I know that I'm going to have 4 terms. And 4. Okay. And the coefficients of these 4 terms, it will be 1, 3, 3, 1. Okay. And then now, let's see what we have for the first term. It will be a to the power 3. And then the next term, I will have a squared. The third term, I will have a. Okay. And then, of course, the last one will be a to the power of 0. Okay. And then now, how about to b? B to the power of 0, then b to the second, and b to the third. Okay. And now if I simplify this, I will get a to the power 3 plus 3a squared b plus 3ab squared plus b to the power 3 then. Okay. Okay. Then let us move to the next. Okay. And now to this one, a plus b to the 4 now. Okay. So then to this one, let us write it out. So it will be a to the 4 plus 4 times a to the power 3b plus 6 times a to the power 2b squared plus 4 a b to the power 3. Okay. And plus b to the 4 then. Okay. So now maybe you could spend some time to work it out. What if you have a plus b to the power 5 then? Okay, just like this. Okay, anyway, then let us go back to this problem now. Okay. So when I have a plus h to the power of 3, okay, then we know that a plus b to the power 3 is a to the power 3 plus 3 times a squared times b plus 3 times ab squared plus b to the power 3, right? So this is what we know. So which is equal to the limit h go to 0, 2 times 2 to the power 3 plus 3 times 2 squared times h plus 3 times 2 times h squared. And then plus h to the power 3 then. And minus 5 times 2 square, first term square plus 2 times the first times the second plus the second term square. Okay. And then plus 4 plus 2h minus 10. Okay. And then now we are going to subtract. Okay. Then let us calculate this then. Okay. Then I will have 2 times 8 minus 5 times 4 plus 4 minus 10. Okay. And everything over h. Okay. So now we will have 2 times 8 plus 12h plus 6h squared plus h to the power 3 minus 5 times 4 plus 4h plus h squared plus 4 plus 2h minus 10, and we subtract. Okay. 16 minus 20 plus 4 minus 10 all over h. Okay. So I have 16 plus 4 equal to 20. And now let's take care of this. So I have 2h to the power 3. And then now 12 minus 5 is 7, h squared. 24h minus 20h plus 2h. So in this case right here, I will have 6h. So I have 16 minus 20 is -4, plus 4 is equal to 0. So I will have negative minus 10 plus 10 is equal to 0 then. Okay. Is all for h. So again, basically the number, they all cancel out. And then now I could factor the h. So I will have 2h squared plus 7h plus 6 over h. Okay. H and h cancel. And then we work with the direct substitutions. Then we could have 2 times 0 squared plus 7 times 0 plus 6. So my answer is 6 then. Okay. That means in this case, my f prime of 2 is equal to 6. Okay. And now let's see how we find the tangent line now. So the slope of the tangent is f prime of 2, which is 6. The point is 2f of 2. Okay, again, f of 2 is equal to 2 times 2 to the power 3 minus 5x squared plus 2x. and minus 10. So it will be 2 times 8 minus 5 times 4 plus 4 minus 10. Okay. So this will be 16 minus 20 plus 4 minus 10. So this cancel out. So the answer will be negative 10. And the third, we would like to work with the Poinslow form, right? Y minus y sub 1 equal to m, x minus x sub 1. Okay. Then you will get the answer is y equal to 6x minus 22 then. Okay, so then now let us look at our next example now. So to this one, it said that if an equation of the tangent line to the curve y equal to f of x at a point where x equal to 2 is y equal to 4x minus 5. Then I hope that when you read the problem, you know that y equal to 4x minus 5 is the tangent line. Okay. And now what I would like to do is I would like to find f of 2 and f prime of 2. Okay. Okay, so let us think about this problem here. Okay, so consider that we have a functions. And then we have a tangent line is okay, is actually with this again, in this case will be y equal to 4x minus 5. Okay. Then now let's think about this. So if you have a tangent line at x equal to 2, meaning in this case right here, they are going to intersect at, again, maybe they share the same point, right? At x equal to 2. Okay. So in this case, it means that to this point right here, it will be 2 f of 2 now. Okay. And of course, you will see that the output f of 2 basically is, you could use this tangent line right here to actually to help you to evaluate because they are at the same point. Okay. So meaning what? To this one at x equal to 2, okay, then f of 2 basically is equal to, again, this equation when you evaluate at 2 then. Okay. So meaning f of 2, basically it will be 4 times 2 minus 5. So which is 3. Okay. Then now let us look at the f prime of 2 now. Okay. F prime of 2 is mean the slope of the tangent line at x equal to 2. And in this case, the tangent line is y equal to 4x minus 5. and the slope of this line right here is 4. So now we know that f prime of 2 basically is equal to 4 then, right?